Hello guys, this is Prime Concept. You're welcome once again to my channel. If you are new to this channel, please do well to hit the subscribe button. You'll be getting valuable contents in physics, chemistry, and maths. In this video, want to look at index of complex number I. We want to see how to evaluate I when it is raised to a power, a natural power. That is what we want to do in this video, and we'll be simplifying the concept. So say we have I raised to some power n, where n is a member of the natural numbers. That is to say that n, for this case, n can only be whole numbers. Positive whole numbers is what we want to consider in this case. So how do we evaluate this kind of powers? Say you have I raised to power 20, I raised to power 30, I raised to power 2000, and so on. Now, very quickly, we want to first lay a background for this. Now, there are certain powers we need to already know, which we're going to do now. Now, first, we need to know that I to power 1 is actually the same thing as I. This is very obvious. Secondly, I want us to know that I to power 2 is equal to what? Minus 1. Because let's quickly show how it becomes minus 1. So I have I times I. That is what I to power 2 means. I times I. And remember, I is actually square root of minus 1. This is square root of minus 1. So that when you multiply them, you say square root of minus 1 times square root of minus 1. From your sword, when you multiply two swords, what you have inside becomes the answer. So I would say this is minus 1. So for short, I squared is actually minus 1. Also, I want us to also know what I to power 3 would be. I to power 3 simply means I times I times I. And this is going to be, remember, I times I is already minus 1. Minus 1 times I is minus I. So you need to know this. Also, finally, you need to know what I to power 4 would be. I to power 4 is I times I times I times I. Now, I times I is minus 1. I times I is minus 1. So minus 1 times minus 1 becomes plus 1. Now, this is where I would stop because these powers are actually periodic, which simply means if I should go to I to power 5, it will give me back I. If I go to I to power 6, it will give me minus 1. If I go to I to power 7, it will give me minus I. If I go to I to power 8, it will give me 1, and it repeats. So it means it is periodic for I to power what? 4. So it means if you can know this, then we can use this concept to shorten the solution for every other power that is above 4. So let's quickly note how we can solve this. Now, I raised to power n, where n is now above 4, would be equal to I raised to power r, where r is the remainder. Where r is the remainder when n is divided by 4. So this is how we can solve problems. That is to say, if they give us a power I to any power, all we need to do is to quickly divide that power by 4, then the remainder is the same thing as I to that power. Let me take a very simple example. Say I have I to power, let's say I to power 6, for example, just a small case. We want to evaluate this. So what I'm going to do is to say 6 divided by 4. 6 divided by 4 is going to give me 1. Then remaining what? It will remain 2. So it means that I to power 6 is actually equal to I, same thing as I raised to power the remainder, which is what? Which is 2. And then what is I to power 2? I to power 2 is minus 1. So it means that I to power 6 is actually going to be minus 1. So let's take a higher power. Now say we have we want to evaluate I to power 15. So let's see this. I'm going to quickly say 15 divided by 4. So if I say 15 and 4 in 15, it would give me 3, so that you know that 4 times 3 is 12. So 15 minus 12 is 3. So the remainder is going to be 3. These are remainder 3. So what it means is that I to power 15 is same thing as I to power the remainder, which is 3. And we already established that I to power 3 is minus what? I. So you can see how simple it is. Let me solve the bigger power again. Now say we have I raised to power 625. So this power is quite big. So we're going to still see how to reduce this. Now this is going to be, I would say 625 divided by 4. So let's divide this. 4 in 6 is going to give me 1. Remember 2. If I put the 2 here, I have 22. So 4 in 22 is going to give me 4 in 22. 4 times 5, 20. So it's going to give me 5, remainder 2. So if I put the 2 here, I will have 4 in 25. That is going to give me 6, that is 24. 6, remainder 24, 25, so remainder 1. So I have a remainder of 1. So this is what I have. So what it means is that I to power 625 is same thing as I to power 1, which is actually what? I. So you can see how simple this is. Let me take one more example, then I will drop for you to solve if you really understand what I've explained. This is really a shortcut for solving powers of I. Now say we have I raised to power 1, 2, 4, 2. Let's say we